Hey, welcome back to this popular TTG channel specially planned and designed for those who are facing challenges while giving technical interviews. Let's discuss today on OPS concept in Python language. If you are giving interviews back-to-back and you think OPS is easy, this video might actually save you from rejection. Because interviewers don't reject you for writing wrong code. They reject you when your object thinking is weak. On top right corner, you will find Python playlist link for your reference. You must listen that too. This video will cover class versus instance variables, mutable default arguments, is vs equals, composition versus inheritance. Most candidates answer these confidently and still get rejected. In the next few minutes, I'll show you 4 real OOP traps that interviewers use through simple Python snippets. And I want you to pause, think, and answer like it's a real interview. Let's start.
All right, we're about to dive into some of those classic Python OOP interview questions. You know, the ones that are designed to do more than just test your memory. These are the questions that show an interviewer how you actually think about code, and honestly, they can be the thing that stands between you and a brand new job offer.
So picture this, you're in the final technical round. Your dream job is literally on the other side of this one conversation. The pressure is on. Let's get into it.
The interviewer passes you this little piece of code. Looks simple enough, right? And they ask, what's going to be printed? Just take a second, look it over. What's your first instinct? Go ahead and lock in your answer. Are you thinking XYZ?
Well, if you said XYZ, you just walked right into the first trap. The correct answer is actually ABC. Now, this isn't just some mean trick. It's a really fundamental test of how you understand Python handling data for a class versus the individual objects or instances that you create from it.
So here's the deal. Company starts its life as a class variable. That means it's shared by every single employee object we make. But then when we run that line e1.company equals XYZ, something interesting happens. It doesn't change the original class variable. Nope. It creates a brand new instance variable just for E1 that kinda hides or shadows the class one. The second employee, E2, never got that new variable, so when you ask for its company, it just looks back up to the class and finds the original ABC.
Okay, so we've seen how Python draws a line between data that belongs to the class blueprint and data that belongs to an individual object. But that idea goes way deeper. Let's take a look now at how Python understands the actual identity of an object in its memory.
All right, next challenge. We've got 2 lists here, A and B, and they look totally identical. The code then prints 2 different comparisons, A equals B and A is B. So, what do you think? What's going to pop out on the screen? Is it true, true, or maybe true, false?
The correct output here is true, false. And man, this is another one that trips people up all the time. The first comparison, with the double equals, is true, because yeah, it's checking if the values are equal and the contents of both lists are exactly the same. But that second one, that one's false. So why is that? Here is the absolute core difference you have to know. The equals operator is all about equality. It asks, do these 2 things have the same value inside them? But the is operator is about identity. It asks a totally different question. Are these 2 variables pointing to the exact same object in the computer's memory? In our little example, A and B are 2 completely separate lists that just happen to hold the same stuff. They are equal, for sure, but they are not the same thing.
Okay, get ready, because this next one is responsible for some of the sneakiest, most frustrating bugs in all of Python. We have a function here, addItem, that just adds something to a list. We call it once with the number 1, then we call it again with the number 2. What do you expect the output to be?
I mean, almost everyone's first guess is that it's going to print 1 and then 2. It just makes sense. But that's not what happens. The actual output is 1 and then 1, 2. Whoa, it's like the list from that first call somehow survived and got used again in the second one.
Well, that's because it did. This is the infamous mutable default argument trap. That default list, the items equals empty part, it doesn't get created fresh every time you call the function. It gets created one time and one time only, when Python first defines the function. That means every single call to add item that doesn't provide its own list is using and changing the exact same list object in memory. Knowing this is so important for writing predictable code. So we've covered data and we've covered object identity. Now let's shift gears and focus on an object's behavior.
Specifically, how methods work when you start bringing inheritance into the picture.
Okay, here we've got a super simple parent and child class. You'll notice both of them have a method with the exact same name, show. So we create an instance of child, and we call it show method. What happens? Does the parent's method run? The child's? Maybe both of them?
A really common mistake is to think that maybe inheritance somehow chains the calls together, so maybe both would run. But the right answer is that only child will be printed. This is the core concept of what we call method overriding.
So what is method overriding? It just means that a child class can provide its own, specific version of a method that its parent already has. The child's version completely takes over and replaces the parent's. Now, if you wanted to add to the parent's logic instead of just replacing it, you could. You just have to explicitly call it using the super function from inside the child's method.
Okay, so far we have been deep in the nitty-gritty of how Python's OOP works. But senior level interviews, they demand more than just knowing syntax. Interviewers really want to see how you think about design and architecture.
So take a look at this code. We've got a car class and an engine class. When a car is created, it makes an instance of an engine for itself. Now the interviewer asks a really simple question. Is this inheritance? You know, it might feel like they're related in some kind of parent-child way, but the correct answer here is a firm no. This is a textbook example of composition, and knowing the difference is just absolutely fundamental to writing good object-oriented code.
The difference really just comes down to two simple phrases. Inheritance represents an is-a relationship. For example, a car is a vehicle. Composition, on the other hand, represents a has-a relationship. A car has a engine. Knowing which one of those relationships fits your problem is a huge part of being a strong designer. So, what's the big picture here? What's the real takeaway from all these traps? The interviewer isn't just trying to be clever. They are probing your deeper understanding. They want to see if you get object life cycles, if you understand encapsulation, if you've thought about these design principles. What they're really asking is, can you write code that's robust and easy to maintain? At the end of the day, these interview questions, they're not just puzzles that you have to solve. They're miniature design challenges. The little snippet of code they show you, that's the question. But the real test is whether your understanding of these deep core principles can be the foundation for a strong, well-designed answer.
If you felt confident while watching this, good, but confidence alone is not enough. In real interviews, interviewers are not testing your syntax. They are testing how you think about objects. One wrong assumption, instance versus class. Identity versus equality. Has a versus is a, and the interview is already over. So before your next interview, don't revise definitions. Revise how Python objects actually behave. If this video made you pause and rethink your answers, you're already ahead of most candidates. Follow for more real interview traps, because interviews are not exams, they are filters. And before we end, I would request you to please share this video with your friends who are in real need. They even don't know where they are missing in logics, and you also subscribe this TTG channel with bell icon to know about more upcoming videos. Thank you.